Okay, so this question is an empirical formula question, and we're just going to set it out in a table format because it helps you structure your answer a little bit easier. So it's actually giving me the overall answer. So the point of this question is to show you're working. And in general, with empirical formula questions, you should always show all steps of your working, because you get marks for the different steps. Right, so firstly what we're going to look at is the different elements that make up this compound. So it's carbon, it's hydrogen, and chlorine, and I like to do it in this sort of format. You notice in this question it gives you the percentages of that compound, and what you always do is you assume that you have 100 grams of the compound, and therefore those percentages become grams. So whether it gives you a percentage or grams, treat it exactly the same. So let's write those percentages or grams underneath each element. So 37.8 for carbon, 6.3 and 55.9. Right, and like with all these mole calculation questions, first thing you want to do is work out the moles that you've been given. And if I remind you what the formula for moles is, moles equals mass over mR, or the relative formula of mass. Right, because these are elements, it's not technically mR, it should really be the relative atomic mass, or the AR. So if I get rid of that, and I'll put AR for relative atomic mass. So that's essentially that's the mass number in the periodic table. Right, so for carbon, 37.8 divided by mass number of carbon, which is 12, and that equals 3.15. Then for hydrogen, 6.3 divided by 1, so that's nice and easy, 6.3. And then for chlorine, it's 55.9 divided by mass number of chlorine, which is 35.5. And that should equal 1.5746. Right, if you think back to what the definition is for empirical formula, it is, I'm just going to highlight empirical formula, so it's the simplest, and this is important, whole number ratio of the different elements in a compound. So it's simplest whole number ratio of the different atoms of different elements in a compound. So I've got moles over here, but what I want is a whole number ratio of moles on here. So the way to do that is to find the smallest of these three numbers, and that's obviously this one, 1.5746. And what you want to do is divide all of those numbers by the smallest number, which is 1.5746, and that's what we're going to do first. 3.15 divided by 1.5746, that should equal approximately 2.00 or something. And then I'm going to do 6.3 divided by 0.576, and that equals 4. And then the last one, you divide 1.5746 by itself, and that obviously equals 1. So now I've got a whole number ratio, and that's 2 to 4 to 1. So the last thing we're going to do is just write the answer out. So C2H4, and then it's just 1 Cl, so Cl, and we've shown our working on that. That's how you do it. Right, once we've worked out the empirical formula, we're going to have a look at the next part of the question, which is on the second slide, and that's this. So it's now following on from the previous question, and I've just write down what the empirical formula was. So it's C2H4Cl. So that is the simplest whole number ratio of the different atoms in a compound. What the next part of the question is asking is to work out the molecular formula, or the actual number of each type of atom in the compound. So molecular formula is the actual number of different atoms in the compound. So we know the empirical, the simplest ratio, and now we want to work out the molecular. And what it's saying is, in this part, is that the actual compound has a relative formula mass, or an MR, of 127. So what we need to do is work out what the relative formula mass, effectively, of the empirical formula is first, because my molecular formula is going to be a multiple of this number. So if I do that, I want to work out the mass of this empirical formula. So we look at the mass numbers in the periodic table, which for carbon is 12. I need to multiply that by 2. I know the mass number of hydrogen is 1. I've got 4 of them, so times that by 4. And then I know chlorine's is 35. 5. Add all of those numbers together, and you should get 63.5. So that's my mass of my empirical. Right, so now we know effectively the MR of my empirical formula. I need to work out how many times that fits in to molecular mass, the relative formula mass of the actual compound. So what we want to do is take the MR that you've been given, 127, and divide that by the mass of the empirical formula, 63.5. That equals 2. So that means my actual compound is twice as big as my empirical formula. So if we remember it's C2H4Cl, we know that our actual compound is twice as big as this, so we multiply everything in here by 2. So that becomes C4H8Cl2. And if you want to double check that you've got the right answer, you can work out the MR of this compound and just check that it adds up to 127. So that's 4 times 12, 8 times 1, and 2 times 35.5. And add all those numbers together, and that should equal 127. And that's how you calculate or determine the molecular formula when you've been given the empirical formula and you've been given the MR.